So I'm going to walk you through a couple of rooms, I think approximately 5 rooms. I'm going to show you 2 floors of this, out of these 4 floors, and show you some examples of what we did during UMBO coordination. So now you can see the second floor and one room on the second floor. It's a patient care room, examination room. And let's see first of all how it looks like in 3D. I just turned to find, I turned off a wall so we can look into the room, but we can actually see in the room. Nothing special, I have to say. So we have a casework, the hand sanitizer, biohazard waste bin, a computer that is necessary in such a room, an examination table, also known as bed, and some other pieces of medical equipment. Note that on the walls you can also see the necessary power outlets, data outlets that goes together with the computer, as well as on the other wall which feeds this piece of medical equipment. So this is the 3D view that we quite often reviewed together on the weekly meetings, as well as introducing it to the end users. We not only have 3D views, but we also created 2D views, 2D elevation views. So let me show you a couple of these. You see the same thing as in the 3D view, the casework, the outlets, the waste bin, and the medical computer. On the north elevation, you can see the view of the medical equipment. On the east elevation, we have more things going on. So here is another hand sanitizer that I mentioned that the nurses and doctors would want to use quite frequently, and different kind of power and data supplies. What you may have recognized on the south elevation, let me go back to that, lots of dashed lines, and it is because, as I mentioned, we reused the data coming from the above head coordination, so we actually knew where the standpipes, where the vertical pipes are going to be built and going to be placed in the walls. It's quite important when we talk about coordinating and placing everything in the right location. If we review the same situation in 3D again, and if I turn off this wall to see inside of it, you can see that there is a pretty big diameter of waste pipe which goes from the 3rd floor down to the 1st floor, crossing the 2nd. If I get around it, it's probably more visible. We have some vent pipes and domestic water pipes feeding that sink. Obviously, we cannot really place heavy items on such a big waste pipe, nor electrical equipment around the domestic water pipes. The other beauty of building everything in 3D, and I think I will have a better example for that, but let me mention it here as well, is that we not only built the dedicated rooms which were actually coordinated, but also the neighboring rooms. So when we wanted to locate a power outlet on one of the walls that we coordinate, we actually knew where the other power outlet would go on the other side of the wall. So we could make it simple for the site team, and we could just align them to be able to faster, to be able to speed up their process. So if I go back to the elevation view again, this is the reason of having these center lines showing the actual piping systems in the wall. As I mentioned, I'm going to introduce not only the rooms themselves, but some modifications that were required either by the contractor, general contractor, or subs, or the nurses. And in this room, I can show you a nice example that the nurses asked us to modify. So when they reviewed all these rooms, and we had multiple patient rooms in the building, when they reviewed a few of them, they said that there are doctors who are right-handed and there are other doctors who are left-handed, and we didn't even think about it. And they said that some doctors prefer to stand on the right and the other doctors prefer to stand on the left. So their request was if we can just change the layout and turn this room, for example, to a left-handed room. Obviously, we could do this. It was not a big deal. So let me just show you what we did during coordination. It was this simple. So basically, with a few clicks, we could satisfy the end users and create a few rooms for them which were left-handed instead of right-handed. If we check the same scenario in the elevation view, as that is also automatically updated, you can see now that the north elevation has now the medical screens and the computer, while the south elevation has changed as well, and only that big piece of equipment is standing there. Let me go to another room and show you a different example. I think this example can be applied to any kind of building, because as I mentioned, it's an office space, and such office spaces you could find in any building type. There, for example, you have a reception. This is a nurse station. You could see that in one of my slides in my presentation already. So as I mentioned, we have lots of computers, screens, printers, and casework placed here. It doesn't seem to be complicated to coordinate it. However, surprisingly enough, we found many issues that we had to deal with. I'm going to show you one elevation only. This is going to be the east elevation of this location, and I'm going to show you two issues that we identified on this single piece of wall. As you can already see, here is a note added per meeting. So when our team modeled and pre-coordinated everything, they found that the specifications ask for a computer in this casework. So they placed the casework, but they were wondering where the power outlet and the data outlet can be to feed that piece of equipment. So they made some notes suggesting that we should place power and data outlet there, and the GC together with the owner could verify that it's a good assumption, good suggestion, and we definitely should place some power and data outlet there. As well as in case of this printer, you would think that a printer requires data outlet as well, just like power outlet, and we cannot really see anywhere around this printer. The reason for that is that we took the electrical drawings and modeled everything that we found on them, and actually in this area we found power and data outlet, but it was located wrong, so they wanted to place it behind the casework. If we follow the sequence, the construction sequence of placing a casework and versus building partition walls, we know that partition walls comes first. We place the outlets there, and only after that comes the casework. So it would have been quite a problem if the casework or if the outlets were placed behind the casework. So it would definitely have become a change order that we wanted to avoid. So the thing that we could do is just simply elevate it to the right elevation height. So it's not clashing any longer with the casework, and there is easy access to it above the printer. To finalize the 2D view, we just had to add some dimensions, and it was ready for the nurse's review. I have another example, however, it's not from the second floor. I just copied one example aside the second floor from the first floor, because I think this is what the nurses enjoy the most. So this is X-ray, but let me show you in 3D rather. This is an X-ray room. You can find the examine table again. The X-ray machine, this is represented just simplified with boxes to show the actual space requirements. Note that in the above head we have the holding supporting structure of this heavy equipment. And as you probably know, such a room requires special equipment which is controlling the device, and it requires that the nurses are staying in the actual room, but it's not too healthy to have too many X-rays examinations, so they need a small space which is defended by a shield wall. It's not a simple wall, it has some metal in it, and it's quite thick, so it's not a simple wall. The nurses can stand behind these walls while the X-ray examination is ongoing. So what the nurses said that they would really enjoy if they want to see what they can actually see when the examination is ongoing. They want to have eye contact with the patient all the times. So it was easy to create a 3D view to them and just check what they would be seeing. And we found that not too much. Basically, they would see the leg or the foot of the patient, which is probably not enough. So they asked whether we can just make these windows a bit bigger, because it is not satisfying their needs. Obviously, as we are talking about a virtual environment, it was not a big deal for me to change it and make it bigger. But luckily enough, we were in time, and we could. I mean, the owner could order bigger examination windows, and they could be changed to create a better working environment for the nurses and the doctors. Obviously, if it was only recognized after the opening of the hospital or the medical plaza, it would have been way too late, and changing these windows would have cost much more, because these windows would have been already ordered and placed, and most likely for a few days by changing these windows in these not too simple partition walls, even the X-ray rooms would have been closed. So a few examples from the first and second floor. Let me just jump up to the fourth floor for a second, and I think I will show you an operating room here. It was already in my presentation as well. I just want to introduce one thing that I mentioned on the second floor. So this is an operating room, lots of screens with the necessary data and power outlet, floor lighting, some whiteboard, other screens that go on the walls, the well-known X-ray illuminators, and on the other side of the room, all the necessary switches and thermostats which control the room. What you can probably see already on this view is this is a door, and usually, as you could see on the other elevation views, the thermostats and other switches are placed rather close to the door, so when they enter the room they can control the room. For some reasons it is placed far from the door, and we have a good reason for that. If I go to the other room, I find that here is a OR panel, an operating room panel, and this controls all the electrical happenings in the operating room. And if I go back to my actual operating room, you can see that this is a recessed panel. It's quite a big panel, and would take almost the entire width of the partition wall. Therefore, there is no way that we could route the thermostats in that location. So those thermostats had to be moved a bit further from the door. If we check it in the elevation view, you can see this recessed panel here, as well as all the other well-known plumbing systems going through the room, through the partition of the room. And the last example that I'm going to show you is a recovery room. Holly mentioned that she thought that we only coordinated the walls behind the patients, but we did a bit more. But this was definitely one of our services as well, to coordinate what goes on the head walls and what we want to place on the head walls. The head wall is actually a piece of wall and equipment which carries lots of different medical equipment. We have the bed here. We have computers and different kind of screens. Actually, we have even a television on the wall, so the patient can recover. When the nurses and doctors again reviewed the elevation that we provided to them, they were not fully satisfied. However, we coordinated everything, and that was our first task, to coordinate everything. Second task was to satisfy the end users, and they found that, for example, the nurse calls, the exam lights, and wall phones were supposed to be placed next to the head wall, not on the head wall. So they asked us and the general contractor to change this setup and move all these pieces of equipment to the head wall, because that's much more useful for them.